There are many challenges in push systems that companies face when trying to meet the needs of their customers. Everything from complexities of forecasting your customer demand, lot sizing, costs, waste, and how to understand when you should pull are major factors to consider. Over the next few modules, we will look at each of these challenges as we start to gain not only a deeper understanding of the challenges that are associated with production, but also why a pull system can solve many of these challenges. With this in mind, we'd like to ask you a question. What's your biggest challenge when manufacturing or producing? We look forward to reading all your answers, and we'll see you in the next module as we dig into some of the more obvious challenges that you may face in a production environment. See you soon. There are very few shops in the world that make only one product, and if they do, they are more than likely considering the thought of expanding. In general, this means that companies must develop capabilities as well as capacity to be able to produce a wide variety of products and information. This also means that tools will need to be changed frequently, materials switched out, information changed over, setups broken down and reset up, and many other things so that an organization can produce different types of products and information. This presents yet another challenge of producing information and products. It becomes very difficult to push items through a value stream or forecast them when you must account for the wide variety that your industry might demand. It's true that mass production of a single model simply does not meet the needs of today's competitive markets. Yet, at the same time, lengthy changeovers make it difficult to meet the many different product mixes. You see, if your changeover time is 1 hour, it would be hard to make a wide variety of parts in one day. This is why many companies produce in batches and avoid frequent changeovers. In a pull system, it becomes absolutely critical to reduce changeover times using methods like SMED or the reduce methodology. As changeover times are reduced, you can lower costs, build a wider array of products, and be much more efficient at building to demand. We'll see you in the next module. As you probably heard before, the only thing you can expect with a forecast is that they are always wrong. How wrong is another question. A forecast is a prediction of something to come or in the future, and that means there is always some type of uncertainty. In addition to this, warning, there are many dangers associated with forecasting customer demand. Let's look at a few. First, let's consider variable demand and products. In most organizations, customer demand fluctuates, seasonality occurs, or something influences demand patterns that will cause variability in your demand. In addition to this, many organizations produce many different types of products. As such, companies must take into consideration both the customer needs and the specific product or information that has been demanded. This can make forecasting increasingly difficult as planners must not only identify the demand fluctuations that will likely occur and have a good understanding of what trends are occurring in their industry. This indeed makes more of a volatile situation when it comes to a forecasting environment. Another danger that you must consider when forecasting is lead time. In addition to variable demand and product trends, forecasters must always consider the customer lead time as well as their own personal production lead times. These, as we all know, are almost impossible to forecast. With all of these considerations, you can see why forecasting is so dangerous. A pull system, on the other hand, solves these dangers by putting a stop to all the guessing and forecasting. Remember, forecasting triggers can include raw materials, schedules, calendars, and plans, but they never include a customer order. In a pull system, everything is driven by the customer order, which means your trigger to begin producing is the customer order. Now, before we go, we'd like to challenge you with a question. What problems have you encountered when forecasting customer demand? We look forward to reading your answers, and we'll see you in the next lecture. It's no secret that the costs associated with producing products and services are a top priority for almost every company in the world. The high costs of conducting business can sometimes feel crippling. With this in mind, every company looks to improve their net. And there are only two ways to do this. A company can increase its sales. However, doing this will always require more resources, which in turn will also increase your costs. The other option is to reduce costs. Reducing costs has always been a focus of any organization looking to continuously improve. This presents yet another challenge for a company looking to transition from a traditional push production system into a pull production system. It becomes very difficult to maintain a competitive stance when costs keep rising and you need to maintain a specific profit margin. As such, the Toyota production system, which later evolved into lean manufacturing, has always focused on reducing costs in an organization. Costs in a pull system are much different than the traditional manufacturing approach. You see, in a traditional manufacturing environment, the manufacturer would total up their costs and then add the amount of profit they want to make. In other words, costs plus ideal profit equals sales price, and then they would send it out. As you may have guessed, this creates bidding wars and oftentimes results in a lot of work being done with no generation of demand. In a pull approach, the market sets the price. In other words, your costs are determined by what the sales price is minus the profit you would like to make, or sales price minus ideal profit equals cost. When you look at these two forms of costs, you may think to yourself, they look the same, and in general they are. However, there are a few key differences. Firstly, in the traditional approach, the market continues to adjust and costs continue to rise. In this scenario, there is no incentive for anyone to lower their costs. Next, in the traditional approach, since costs continue to rise, there is a huge risk that the market at some point will reject the selling price, thereby pricing yourself out of the market. Also, in a traditional approach, a lot of work is done prior to any generation of demand. Another difference is that in a pull approach to pricing, if you want to improve your profit margins, you reduce the costs, which does not require any influence of market conditions. It can be done internally by reducing your own costs. Finally, in a pull approach, the market creates the demand and sets the selling price. If after you subtract your ideal profits, your costs are too high, you only have two choices to make. Do I try to lower my costs, or do I place my efforts somewhere else? As you can see, the challenge of reducing your costs or increasing your sales price is a tough one. Which do you do? Inflate your sales price or reduce your costs? The pull approach will always advocate reducing costs, and so do we. We'll see you in the next module. In almost every single organization around the world, waste makes up more than 85% of the production process. Waste can be defined as any activity that does not add value to the product or service. In many cases, waste not only adds no value, but adds costs instead. Waste is amplified in push systems and is drastically reduced when pull systems are implemented. We'll go over more of this later. Nonetheless, this requires a transition from the traditional mindset of working longer, harder, faster, and adding more people and more machines to a lean thinking mindset. A good place to start is understanding the 5 basic principles of a lean organization. Number 1, define value from the customer's perspective. Number 2, see the value stream. Number 3, make value flow. Number 4, establish pull by making only what is considered value. And finally, get a little bit better. Pursue perfection. This mindset is focused on finding and eliminating waste to improve the value stream of a process. Implementing a pull approach to production is a critical method for reducing costs and eliminating waste in any organization. Pull systems are very effective in engineer-to-order environments, make-to-order environments, assemble-to-order environments, and even can help you begin to transition out of the make-to-stock production environment. So, when would you want to consider not pulling? Firstly, it should be known that all companies should consider pulling. There is never a time when demand is not present that a company should tie up resources producing. However, there are times when the benefits of pull systems may not be as obvious as others. The first situation is when the benefits of pull may not be as obvious as others is when a company produces only one product with absolutely no variation in the product. Because there is only one product with no variation to it, you always know what product would be ordered. In this case, many companies opt to make a product to stock and then switch from a push to pull, and that occurs at the end of the value stream. Nonetheless, this still presents a lot of risk, especially if the items being made have a shelf life associated with them. Another common situation where pull may be a bit more challenging is when a company operates in an industry where there are steep fluctuations in demand or seasonal fluctuations in demand. In these types of situations, pull is still very beneficial, but it can be difficult to reduce waste, improve changeovers, and generate triggers that are quick enough to keep up with demand when it ramps up. With that being said, the issue is not necessarily the pull approach when demand fluctuates, It is being able to change over quicker, ramp up production faster, and keep up with the demand in these situations. Nonetheless, whether in a push or a pull environment, it is important to remember that waste occurs in all systems, and you should strive to remove or reduce it to a level that is most advantageous for you. We'll see you in the next module.